Hey guys, Mr. Bowman here. Today's learning objective is in yellow and we are learning to find the unknown sides of angles and right angle triangles. And the trick for today's video is we've been thrown both trigonometry questions and Pythagoras' theory questions, and we've got to figure out which of the rules apply. So let's start off with trigonometry. And then I'm going to write Pythagoras' theory down below. The rule that you need to apply depends on what information you have and what information you're looking for. So the way I think about it, trigonometry, if you are dealing with two sides and one angle, you're going to be needing to use trigonometry. If you are dealing with three sides, and then don't forget, really important, no angles, you're going to be looking to use Pythagoras' theory. So let's have a look at the four questions that I've got here, just to show you what I mean. So if you have a look at question number one, we've got here, here, and here. These are the three things we either know or we're looking for. And if you have a look, A and 10, we've got two sides here. So two sides, and also 45, that's an angle. So we've got two sides, and we've got one angle. We then have to think, well, which of the two rules apply? And yes, trigonometry applies to two sides and one angle. So therefore, this question here, we're going to have to use trigonometry to solve that question. So let's get into the maths of that. So we've got our hypotenuse, we've got our opposite, and we've got our adjacent. We don't care about the hypotenuse, so that means we're left with O and A, and that's the type of our trigonometry functions. So we've got tan angle equals O over A. That means tan 45 is going to be equal to 10 divided by A. A will be equal to 10 divided by tan 45. Just a reminder, if it's on the bottom, or the letters on the bottom, we just switch those around. And then finally, this is where we grab out our calculator, and we're going to do 10 divided by tan 45. 10 divided by tan 45, that is going to come up to 10 as well. So 10 meters. So there we go. We found out that A is 10 meters using our trigonometry. Let's have a look at the next triangle. And we need to investigate the sides and the angles to figure out what rule we're looking at. The first thing I've noticed, we don't have any of these given angles inside that, so it's probably suggesting no angles, maybe trigonometry, and we're dealing with 1, 2, 3 sides. So definitely going to be that. 3 sides, no angles. This is going to be a Pythagoras' theory question. So we've got 3 sides, and I'm just going to write PT, short for Pythagoras' theory. So let's write that down. So we've got A squared plus B squared is equal to C squared. That's our equation. We now need to label our triangle. This time we're labeling ABC. So we've got A and B, they join to make the right angle, and C is opposite the right angle. So these are ABC. So A is going to be 15. So 15 squared plus B squared is going to be equal to 20 squared. B squared is going to be equal to 20 squared minus 15 squared. And the reason I'm doing that, minus 15 is the opposite to that plus over there, or positive. B squared is going to be equal to, I'm going to grab out my calculator for this, 20 squared minus 15 squared. That's going to get me to 175. B is going to be equal to the square root of 175, because a square root is the opposite of a square. Square root 175, and I'm getting 13.2 centimeters, and that they had a 1 dp rounding. So hopefully this is beginning to make sense. Looking at the sides and the angles, let's figure out which rule you're applying. So let's have a look at question 3. We've used the pen color for the last two. Maybe we'll move into the green pen. Here we go, green. So we've got an angle. That's a first thing to note. And we've got two sides. So one angle on two sides. One angle. And if you have a look, two sides, one angle, that's a trig question. We're going to have to use Sakatoa to solve that. So we'll label them. There's the hypotenuse, there's the opposite, there's the adjacent. We don't care about the adjacent. We're left with O and H, which is sine. So sine angle equals O over H. Sine C is equal to 14 over 19. So I'm substituting everything into my equation now. Opposite of a sine, hopefully you remember this from our previous video. Sine, opposite of that is inverse sine. And this is when we're going to grab out our calculator. Inverse sine, and in the brackets, 14 divided by 19. That's going to get me to 47.5 degrees, and that had a 1 dp rounding. So hopefully this is beginning to make sense and you're seeing the patterns come up. And our last question, straight away I'm seeing, well, there's 3 sides, no angles. That has to be Pythagoras' theory. So 3 sides, no angles. So we've got 3 sides, no angles. We're dealing with Pythagoras' theory. So let's write down Pythagoras' theory. A squared plus b squared is equal to c squared. And we're going to go A and B because they join to make the right angle. Opposite to that is going to be C. So A is 8. So we've got 8 squared plus 6 squared is equal to D squared. And in my calculator, 8 squared plus 6 squared, that comes to exactly 100. So that's a nice number. 100 is equal to D squared. I'm going to switch them around. D is equal to the square root of 100. D is equal to 10 meters. No rounding there because it's a whole number. So hopefully this video made sense. Hopefully you know when you use trigonometry and when you use Pythagoras' theory. Thanks so much for watching, guys. Now let's get into heaps of practice.